Yeah, okay. Hello, good afternoon, everyone. So, my name is Ankit Routey. Uh, Today, we are going to learn about number systems. I am currently pursuing Masters in Business Administration from School of Management, NIT ROURKELA. I have cracked various competitive examinations throughout the nation, like CAT, ZAT, and other examinations for TCS Ninja and Digital. So, without further ado, let's get started with our topic today. Number systems. What is the importance of number system in our daily life? So moving on, number system is an all-time favorite with the exam setters as well as the students. The topic is known for intriguing conceptual problems that test the best brains. For this topic, you need to use a combination of pure mathematical knowledge along with logic skills. In fact, this is one of the topics that begins with the absolute basics of mathematics, that is number. It explains to you the different types of number and then extends the application of this knowledge to a variety of domains. The number system is used to count things. For example, how many dogs are there? I'll just count them. To measure the fundamental quantities such as temperature, pressure, etc. There are a number of various different number systems in use, but for our lenience, we'll just fix to decimal number system. Although the more popular number systems in use are binary number system, octal number systems, and hexadecimal number systems. These are something CS background students must be familiar with. So the expected aspects of number system is quite vast and it is most commonly used in our daily life. The number system is such a vast area that the syllabus for the same cannot be defined exactly. So what next comes to our mind is, what is the syllabus of number system? Keeping in mind the concept from which questions can appear in the exam, the main topic of this area include units, digit, reminders, digital roots, divisibility rules, integers, and number of zeros. Besides these topics, questions are also placed on real numbers, prime numbers, natural numbers, and whole numbers. In short, questions on number systems may be based on basic definitions as well as on advanced topics. Moving on to various types of numbers. Natural numbers. All the positive numbers 1, 2, 3, etc. that are used in counting are called natural numbers. So these natural numbers are basically something which we come across almost every day while measuring, counting, or even during basic mathematics. So types of natural number systems can be based on divisibility. So what is divisibility? Divisibility is divided into two parts, prime number and composite number. So in accordance to divisibility, a prime number is basically a natural number which is greater than 1 and do not have other divisors except for the number itself and 1. For example, the prime numbers are 2, 3, 5, 7, 11, 13. Next comes composite numbers. Any number other than 1 which is not a prime number is a composite number. So essentially composite number has more than two factors, that is the number itself and 1. Apart from that, they have more factors such as usually a composite number can usually be expressed in terms of the product of various prime numbers. For example, let's say we took a composite number 4. So 4 can be expressed as a product of 2 and 2. So here two prime numbers can be used to create a composite number. Similarly, if we take 10, so 10 is essentially 2 into 5. Here 2 is a prime number and 5 is a prime number. So moving on to whole numbers. So whole numbers is a superset of natural numbers which includes 0 as well. So including 0, the whole numbers is the same as natural numbers. Now moving on to integers. All the counting numbers, 0, positive numbers, and negative numbers form the set integers. So integers contains all the negative numbers starting from minus infinity to 0. Then it goes all the way up to 0 to infinity. These are all put together called integers. Now, let's move on to rational numbers. So what is a rational number? A number which can be expressed in the form of a fraction. What is a fraction? A fraction is something which has a numerator and a denominator. So here, Rational numbers can be expressed in the form of numerator as well as denominator. So for instance, 2 by 3, 4 by 8, even integers and natural numbers and whole numbers are also rational numbers, because 1 can also be written as 1 by 1, or 3 can also be written as 3 upon 1. So what is not a rational number? There comes the irrational number. Irrational number is something which can never be represented in properly in a fractional form. So what are those? Let's come to them. For instance, let's go to root 2. Now, the value of root 2 is something 1.4 something, but the thing is this cannot be exactly represented in form of a fraction. This is not 14 by 10. So this is a irrational number. There are many other examples such as root over, cube root of various numbers which are not perfect squares or perfect cubes. So the distinction between basically the rational and irrational number is you can just try to express it in form of a fraction. If you cannot do it, then it is an irrational number. Moving on to even and odd numbers. So all of us has learned that even and odd numbers basically comprise all the basis of number system. So starting from 1, 1 is the odd number, then is 2, 2 is the even number, then 3, 3 is odd. So this is pretty much it. Moving on to test of divisibility of numbers. Divisible by 2. So any number which has a unit digit divisible by 2, the number itself is divisible by 2. We'll understand this with the help of an example. Let's say, for example, 34. So in order to check whether the whole number is divisible by 2, we need to take its unit digit 4. So we need to check whether 4 is divisible by 2. So yes, we can see 4 is completely divisible by 2, leaving a remainder of 0 and quotient of 2. Hence, we conclude that 34 itself is totally divisible by 2. Now we'll take a larger number, for instance. Let's say 9,403.68. Okay, let's add another 2 here. So in this number, we can see that the unit digit is 2. So when we divide 2 by 2, we'll get 1. So we can conclude that this number is completely divisible by 2. But if we take a number such as 34,651, here the last unit digit is 1. So we know that 1 is not divisible by 2. Hence, the whole number will not be divisible by 2. Next, moving on. Divisibility by 3. So divisibility by 3 is pretty much unique, and it basically says that you need to sum up all the digits and check whether they are divisible by 3 or not. So we'll understand this with the help of an example. Let's say 369. Here, this number, we have to check whether it is divisible or not. So in order to check, you can use the normal division rule, but it will take some time. So instead, we'll just use the divisibility test. So here, we'll just add, that is 3 plus 6 plus 9. It is 18. So we can see that 3 6 is 18. So since the sum of the digits are divisible by 3, the whole number itself would be divisible by 3. We'll take another example, 541. Here, this number, if we add it up, 5 plus 4 plus 1, this gives us 10. So 10 is not inherently divisible by 3. So since 10 is not divisible by 3, 541 itself will also not be divisible by 3. There is also a catch, which we'll learn in remainder theorem, but we'll see a glimpse of it, that when you divide the sum of the whole thing, if you get the remainder, then you will see that this remainder usually suggests that this number is not divisible by 3. Moving on to divisibility by 9. When the sum of its digit is divisible by 9, the whole number would be divisible by 9. This is pretty much similar to what we saw in divisibility by 3 case. So we'll also understand this with the help of an example. Let's say, for example, 1731. In order to check whether this is divisible by 9 or not, we'll just have to add its number. So 1 plus 7 plus 3 plus 1. Here you're getting 12. So since we know that 12 is 3 multiplied by 4, so this number is divisible by 3. Sorry. We're checking for 9. Okay. So here we'll see that 12 is not divisible by 9. So this number will also not be divisible by 9. Let's say for example 999. Okay. In order to check, we'll just have to add those numbers. So 9 plus 9 plus 9. This is 27. We know that 27 is 9 multiplied by 3. So since 27 is completely divisible by 9, we can also conclude that 999 will also be completely divisible by 9. Next comes divisibility by 4. If the sum of the last two digits is divisible by 4, then the whole number would be divisible by 4. So we'll see. Let's consider a number 17,825. You see, you'll just consider the last two numbers. Here, 25. Is 25 divisible by 4? No, 25 is not divisible by 4. Hence, we can conclude that 17,825 will not be divisible by 4. Next, moving on to divisibility by 8. Divisibility by 8 is similar to divisibility by 4. So here, in case of 4, we need to consider the last two digits, that is the units digit and tenths digit. But here, with divisibility of 8, we'll consider the last three digits, that is unit, tenths, and hundreds. Let's say for a number 864. Okay, let's take it 32,864. So when we need to check whether this number is divisible by 8 or not, we'll have to check the last three numbers. 864. So we'll have to check whether 864 is divisible by 8 or not. So we can clearly see that it is divisible by 8. 8 minus 8, 0, 6, 0, 8. So since 864 is clearly divisible by 8, 32,864 will also be divisible by 8. Okay, let's move on to a little trick here. Okay, so this formula basically comes from because 4 essentially when multiplied by 25 gives 100. So anything which is a multiple of 100 would always be divisible by 4, correct? So we'll just ignore the terms that is beyond the hundredth digit, 100,000, because we know that anything beyond this will be divisible if the last two digits are divisible. Similarly, for 8, if we multiply 125 with 8, we'll get 1,000. So 1,000, so every multiple of 1,000 will be divisible by 8. So we'll just have to check the last three digits. So this is a trick to remember the divisibility by 4 and divisibility by 8 rule. Next, moving on to divisibility by 10. Divisibility by 10 is quite simple. We'll just have to check whether the unit digit is 0 or not. Any number with unit digit 0, 890, since the unit digit here is 0, this whole number would be divisible by 10. Any number, how much long it is, 102340. Since the unit digit is 0, the whole number is divisible by 0. Next, moving on to divisibility by 5. When the unit digit is either 0 or 5, the whole number would be divisible by 5. Let's say, for example, 36455. Here we can see that the last number is divisible by 5. So the whole number itself would be divisible by 5. Next comes divisibility by 11. So this is pretty new and tricky. So if the difference of the sum of digits at the odd places and the even places is either 0 or the difference itself is divisible by 11, then the whole number would be divisible by 11. So for instance, let's take an example, 1331. Okay, let's check. What we'll do is we'll just add the numbers in odd places and we'll add the number with even places. So here we'll add the odd places. Okay, the first with this, that is 1 plus 3. You get 4. Now we'll add the number in the even places. There is also 1 plus 3 is equal to 4. Now we'll have to find the difference between the two. So the difference between the two would be 0. So hence, going by the divisibility rule, we conclude that since the difference between the sum of digits of odd and even places is 0, we conclude that this whole number is divisible by 11. Next, moving on to one of the most important term in number system, factorial. So what is factorial? Factorial of a number was denoted by Christian Kramp in 1808. So it is basically calculated as the product of all positive integers which are less than or equal to the number itself. So let's say we are calculating the factorial for 6. Factorial is usually denoted by this sign, exclamatory sign. So 6 factorial is essentially 6 multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. So it goes all the way up to 1. So the general formula for n factorial would be n factorial equals to n multiplied by n minus 1, n minus 2, and it goes all the way up to 1. So what is the significance of n factorial here? So n factorial is basically the number of ways we can arrange n distinct objects into a particular sequence. Here, 2 factorial essentially means 2 objects that need to be arranged. So 2 objects can arrange either one after the second or the second comes after the first. So we have just 2 sequences. So hence 2 factorial is equals to 2. So let's say we have 3 objects here. Okay, let's say we have 3 alphabets, A, B, and C. We need to arrange them. So how do you arrange them? So in order to arrange, you'll see you'll have many combinations. First would be A, B, C. This is one combination. Then what you can do is A, C, B. This is another combination. So moving on, this will be hectic. But if we just use the factorial formula, it would be multiplied by 2 multiplied by 1, which is essentially 6. So we can see that 3 objects can be arranged very beautifully in 6 ways. So now looking at an exception, how can you arrange 0 object? So if you do not own anything or you do not have anything, there is only one way of arranging, that is the object does not exist. So 0 factorial is always equals to 1. So now let's see some complex topics on natural numbers. See, we need to find the last 2 digits of 78 square. So the prerequisite here would be to memorize the square of all 25 natural numbers, first 25 natural numbers that is. So we'll see that whether is 78 close to any 100 or 50. So we know that 78 is close to 100. So we'll express 78 in the form of 100 minus 22. So why are we doing this? So this basically is to use the formula a minus b whole square. That is a square minus b square plus b square minus 2ab. So if we can just represent 78 or in this case any number in this form, then it would be very much simple to solve it, because you see 100 square will lead to 10,000. So the last 2 digits are 0 and 0. Next we'll see this term minus 2ab term. This term also has 100 in it. So the last 2 digits will also be 0. So we're just concerned with the last term, that is the square of the last 2 numbers. So here we have 22. So 22 square is 484. So the last 2 digits would be 84. So since this was 78, any number you can think of can be expressed in the term of 100 minus something or 50 plus something. Like we'll see in this case, 61 square. Here we'll see 50 plus 11 is 61. So we'll just express it in a plus b whole square term. If we expand this, we'll get, let's just expand this here. 50 square plus 2 multiplied by 50 multiplied by 11 plus 11 square. So 50 square here would lead to 2500. The last 2 digits here are 0. And here we have 50 multiplied by 2, which is essentially 100. So the last 2 digits again are 0, 0. So we'll just have to solve this value 11 square, which would be 121. And the last 2 digits we can calculate easily as 21. So every number you can think of, you can find the last two digit of square using this formula. So moving on, finding the tens place digit of any number with unit digit equals to 1. Okay. So for example, here we have considered 31. 31 raised to the power 76. Okay. So the trick to finding the last digit of any number ending with 1 is to find the unit digit of the product of the unit digit of the power and the tenth digit of the base. So it is clear that the here unit digit is 1 and we have to identify the tens place digit of the same. So in 31 raised to the power 76, the base here is 31 and on tens place we have 3 and on units place we have 1 and the power is 76 whose unit digit again is 6. So the second last digit of 31 raised to the power 76 would come down to 3 multiplied by 6, which would be 18. So we'll just use the last digit, which is 8. Therefore, the last two digits, therefore, the last two digits would be, last digit would be 8, and the last but one digit would be 1, which we can see here. Next, moving on to the questions. Okay, so now I'll be solving these questions. So let's see whether you can solve it faster or me. Okay. The question here is n is 18n square plus 9n plus 8 upon n. So where n belongs to an integer. How many integral solutions of n are possible here? Let's see. We can write it in this form: 18n square plus 9n plus 8 upon n. If we just solve it, we'll just see 18n plus 9 plus 8 upon n. So we can clearly see that this term and this term will always lead to integers, correct? So we are just concerned with this term. So in order to find the number of integral solutions, we'll just see for how many values this last term comes upon to an integer. So n can assume various values. What values can it assume? So in order to find the values that n can assume, we'll just have to find the factors of 8. So 8 here is 2 multiplied by 2 multiplied by 2. So here the factors of 8 would be, and obviously 1, because 1 is the factor of every number. So here the factors of 8 to 1, 2, 4, and 8. So n can assume these values. But think again, can n assume only these values, or it can assume also negative values? Because we know integers go all the way up from minus infinity to 0 and from 0 to positive infinity. So n here would also assume negative values, that is -1, -2, -4, and -8. So all of these add up to 8 values. So our answer of the question would be 8. How many integral solutions of n are possible? 8 solutions. So here you can see the solution. If anyone is having trouble, I'll wait on this slide for 30 seconds. You can just go through. Let's move on to our next question. Here, n is 960. So find the total number of factors of n. How do you do that? So in the previous case, we had a simple number 8. So the finding factors of 8 is pretty much easier. So here we have a bigger number, larger number. So what would you do? Let's move on. So the basic, we'll learn a formula here. That is the number of divisors of a composite number, D. Here, D can be represented in the form of A multiplied by P, P multiplied by Q, C multiplied by R, where A, B, and C are prime numbers, and P, Q, and R are the respective multiples of prime numbers. So this need not necessarily be the three prime numbers. A number can be product of more than 3 prime numbers, but this is just for demonstration here so that you guys will understand it better. So we see that P plus 1, Q plus 1, and R plus 1. The product of these 3 values would give us our answer to the number of factors of a composite number. So following this formula, if we multiply 960 into prime numbers, how many prime factors are there? Okay, for 960, we can say this is divisible by 2, this is divisible by 3, this is divisible by 5. What else? We can't just see anything because we can just solve it with these three. So let's see. 5 multiplied by 26 would give, sorry. We'll see 2 multiplied by 25 will give 50. Then we'll see 30 multiplied by 3 would give 90. Then we'll see 51 multiplied by 50 multiplied by 5 would give 250. If we just add this up, this will constitute 960. So following the same, after dividing 960 into prime factors, 26 multiplied by 31 multiplied by 51, we can calculate the total number of factors as 6 plus 1, 1 plus 1, and 1 plus 1, which would be 7 multiplied by 2, 7 multiplied by 2 multiplied by 2. That would be 28. Okay. Now, let's see to find the unit digit of the following expression. 123 raised to the power 34 multiplied by 876 raised to the power 456 multiplied by 45 raised to the power 86. So you see, this questions proved to be quite difficult in nature, but if you just see this question closely, you guys will notice something. Can any one of you just see it? You can just write it in the comments. Okay, so I'll just give you the answer. Here we have 5 in one of the numbers, which is raised to power 86. So since we have a 5 here, and this number 876 is essentially a multiple of 2. So it can be like 876 can be represented as 438 multiplied by 2. So in this whole product, we have taking this, like this value, this can be written as 438 multiplied by 2 raised to the power 456. And here we have 5 multiplied by 9 raised to the power 86. So here if we just solve it, we'll get like, just take this value 2 raised to the power 456 and just take this value multiplied by 5 raised to the power 86. We'll see we have various 2s and 5s which are multiplied, which will give a value of 10. There are multiple values of 10 here, like at least 86. So we'll see that the last 86 digit of this formula will contain 0. So this answers our basic question. The unit digit of the following would be 0. So you need not have to solve it. You just have to look at the trick. So this is the solution. You can just go through. Okay, moving on. What will be the number of zeros at the end of product of first 100 natural numbers? So the approach to this question would be, we can clearly see this is a question from Factorial. Okay. So the product of first 100 natural numbers would be 100 multiplied by 99 multiplied by 98. So this is essentially 100 factorial. Okay. So if this questions can be phrased in a different way, what will be the number of zeros at the end of 100 factorial? Oh, it could be something like that. Okay. So you need to just see through the question and solve it for yourself. So this all goes up to 97. This multiplies by goes up to 1. Since it says the first 100 natural number, right? So here we'll just see which is the greatest power of 5. That is what we need to find. We have to find how many zeros are there at the end of 100 factorials. How many zeros? Okay. So remember, multiple of 5 multiplied by any number gives 0. So we have many 2's here. So we need not concern ourselves with the 2's, but rather we should just see the number of 5's present. Okay. So in 100, we can see 100 is essentially 25 multiplied by 4. So 25 has two fives. Okay, we have two five here. Next 95 contains one five. So this, in this way you can find it and add all the fives, and the number of fives there would always be equal to the number of zeros. But still, this is quite hectic if the number is large. Let's say it was 18,900 factorial. So it would be not viable for you to calculate in that way. All right. So what we'll do here is we'll take a simple formula. We'll just divide 100 upon 5. So we'll get 20 as a quotient, and then again divide 20 by 5. We'll get 4 as a quotient. So here 4 cannot be further divided by 5, right? So the sum of all the quotients that gives you the greatest power of 5. So here we have 20 and 4. So if we just add them, we'll get 24. So we can see that there are 24 fives in 100 factorial. Okay, 100 factorial has at least 24 fives. And this is multiplied by some other value which I'm not concerned with, since we are just here to find the number of zeros. So since we have 24 fives here and the number of twos are just way beyond that, so we can clearly see that we have at least, let me just write it here. Where am I? Yeah, there are at least 24 twos, and there could be many other twos which we are not concerned with. So we can see that this is essentially 10 raised to the power 24, which would be 1 after 24 zeros. So we can clearly see here that we will have 24 zeros at the end of the number. I'll just erase all the ink so that you can see the solution clearly. Okay. Now this is a pretty tricky question. Which letter should replace the dollar sign in the number so that it becomes a multiple of 9? Okay. So we'll just go back to the divisibility of 9. Do any of you remember what divisibility of 9 was? Let's just go back to that slide. So this is the divisibility of 9. So what does it say? It basically says that when the sum of digits is divisible by 9, the whole thing would be divisible by 9. Correct. So moving on to the question at hand. Oh, where was I? Yeah. So we need to see whether this number is a multiple of 9. So if this number is a multiple of 9, then it should be divisible by 9. Correct. So if it is divisible by 9, we just have to find the value of dollar, which makes the sum of the digits of this number divisible by 9. Okay. So we'll just add this up. Okay. 2 plus 3 plus 4 plus 7 plus this dollar. Dollar here is the variable. Okay. Plus 9 plus 8. Just add 2 plus 3, 5 plus 4, 9, 7, 16, 16 plus 8, 24, 33. Okay. 33 plus dollar sign. So this should be a multiple of 9. Okay. This n just represents a product that should be multiplied with 9. So we'll see the closest value of like n, which will satisfy the equation. So that would be 4. Okay. So this should be 36. So if this is 36, then like the product, like whole the sum should be 33 plus dollar should be equals to 36. So we can clearly solve this. Dollar equals to 3. So if this number instead was 3, this becomes a multiple of 9. So here's the solution. You guys can walk through it. Okay. Moving on. In a party, there are 20 persons present. If each of them shakes hand with all other persons, in total, how many handshakes will take place? Let's say for in this session, we have 20 people here. Okay. So if each of us, let's say, sends a greeting message to one another, so we'll just take the greeting message as a handshake. So if one of you sends me a handshake, then I need not send you the same. So how many greeting messages will be there? All right. So let's see how to approach these type of questions. So going by the basic rules, out of the 20%, the first person will shake hand with 19 others. the second person will shake hand with 18 others, because the first person has already shaken hands with the second person, so he need not shake hand with the first person. Okay, so and going on, the third person will shake hand with 17 person, and so on. So the second last person will shake hand with just a single person, and the last person will shake with none, because everyone has shaken hand with him. All right. So we'll just have to find the sum of the handshakes. So we'll see the 20th person does 19 handshake, 19th person does 18 handshake. Going by the same formula, we'll see the second last person does a single handshake, and the last person does no handshake. So if we just add these handshakes together, we can clearly reach to a conclusion, the answer we are seeking. So essentially it is 19 plus 18 plus 17, and it goes all the way up to 1. Okay, so it essentially boils down to the sum of first 19 natural numbers. Okay, so we have a trick for that. So you guys should better remember it, the sum of first n natural numbers. I'll just move on to that where it is. Yeah. So the sum of first n natural numbers, so this is represented by sigma n, is n multiplied by n plus 1 upon 2. So we'll just take a example, 19. So sigma 19 would be 19 multiplied by 19 plus 1 upon 2, which would essentially be 19 multiplied by 20 upon 2. So this would be 190. So let's see if a solution matches the answer or not. Okay, see, 190 handshakes. So this is one of the most crucial formulas. Obviously, you'll be given a PDF for the same, but still try to remember it, because it will come handy with other calculations also. Now next, come to some of the shortcuts which will help you solve questions quicker. No doubt you can solve the questions with the fundamental approach, but this will save you some crucial time which you could allot to other questions which needs your attention. Okay, so coming down to shortcuts, every number has the same unit digit as its fifth power as it has its first power. So basically here we can see that every unit digit repeats after 5 powers. Okay, so essentially we can see that let's say 2. Okay, 2 raised to the power 5 is 32, correct? So we'll just find the next fifth power of 2. So fifth means from 5 we'll find the next fifth value. So next would be 2 raised to the power 9, which would be 512. So here we can see that clearly the unit digit repeats. Okay, so if you just move on to find 2 raised to the power 14, it will repeat again. Okay, so you can see that the fifth power always repeats as a unit digit. So where it will come handy? It will come handy when you know a certain power of a number. Let's say you remember just a second. Yeah, you remember 25 raised to the power 2. Okay, this is quite simple. Let's come to 16 raised to the power 2. This will also come as 6 always. Okay, 13 raised to the power 2. Okay, 13 raised to the power 2 is 169. So if you just go to its fifth power, so fifth power from 2, you'll count the fifth value. Who is the fifth from 2? So it will come as 13 raised to the power 6. You'll see 13 raised to the power 6 will always have a unit digit 9. You can just solve it if you want. And this applies to any power of 13. So it can essentially be written in the form of 13 raised to the power 4n plus 2. So this value of n can take any value, and if we will just assign the value n equals to 1, it comes down to 13 raised to the power 6. N equals to 2, it comes down to 13 raised to the power 10, which again will have the same value 9. Okay. So next, moving on. This is something we have seen for calculating the number of zeros at the end of a factorial. You should just divide the number by 5, and the quotient obtained should again be divided by 5. And this should be done until the quotient is not divisible by 5. So then you can just sum all the quotients and the number itself would be divisible by 5. So we can see we have solved this. Yeah, this question, 100. We have solved it and we got to 24. That is 100 divided by 5, we'll have 20. Then 20 divided by 5, we'll have 4. Yeah, 20. So if we just add 20 and 4, the sum is 24. So the number of zeros at the end of the product of first 100 natural number would be 24 zeros. Okay. The digital root of a number is the sum of digits over and over again till it becomes a single digit number. For example, the digital root of 87,984 would be, you just add it up, then again the value, then add it up again, and you'll value 9. So just remember it, because sometimes they ask for the digital root of a number and you might not know what it is. So it is essentially, you will just keep adding the number until you have a single digit number. Okay. Moving on, the product of three consecutive natural number is always divisible by 6. Okay, so like this is something you should remember, but I can just verify it for you. Let's say 12 multiplied by 13 multiplied by 14. So it says that it is always divisible by 6. Why it should always be divisible by 6? So we'll see. 12 is essentially 6 multiplied. Okay, this is multiple, but it can be represented as 3 multiplied by 4. And here 14 is 2 multiplied by 7. So if we just multiply 2 with 3, we'll get 6. So anything other than that are just like something which are multiplied by 6. So the whole thing would be multiplied divided by 6. And the same goes for the product of three consecutive natural numbers, the first of which is an even number, is divisible by 24. So let's just verify with the smallest three consecutive natural numbers, the first of which is an even number, 2, 3, and 4. Okay, so if we just multiply these three, 2 multiplied with 3 multiplied by 4, you'll just get 24. You can just try it with any other values, 6 multiplied by 7 multiplied by 8. Here we have 6 and 8 is essentially 4 multiplied by 2. So if you multiply 6 is multiplied by 4, we'll get 24, which again is multiplied with some other value which we are not concerned with. Since it's multiplied by 24, the whole thing would be divisible by 24. So these are the two things you should remember. Next, moving on to the sum of a two-digit number and a number formed by reversing its digit, always divisible by 11. Okay. So this is something like we can see here, 28 and the reverse of it, that is 82, is 110, which is divisible by 11. So it applies to almost everything. Okay. And there's also a catch to this. At the same time, the difference between the numbers will always be divisible by 9. Like here we can see 82 minus 28 is 54, which is divisible by 9, because 54 is essentially 9 multiplied by 6. This I've explained it before. The sum of first n natural numbers is n multiplied by n plus 1 upon 2. Next, moving on to the sum of n square. That is the sum of first n perfect squares. Okay. So here perfect square means, so sigma n square essentially for n equals to, let's say, 4. This essentially 4 square plus 3 square plus 2 square plus 1 square. So this like just needs some effort to solve, but instead we have a very handy formula for it. So if we just solve it, it will be 16 plus 9 plus 4 plus 1. So it will be 16 plus 9, 25, 29, 30. Okay. And if we just solve it using this formula, sigma 4 square equals to 4 multiplied by 4 plus 1 multiplied by 4 plus 2 upon 6. I think there are some issues here. This formula is not 4 plus 2, 6, 4 plus 1, 5, 4. This should be 20. There's something wrong with this formula. Okay, we'll just come back to it later. I think the formula is wrong here. Okay, now this comes to n cube. The same formula, it can be extended to n cube. Uh, you guys just leave it. I'll just brief it in the next classes because there's something wrong with this formula. So this formula holds. Okay. Now moving on to tips and tricks which you should follow while answering questions from number system. Just get the basic understanding of numbers and always be careful when you attempt a question and identify the type of question the question probes. And there is significant difference between real numbers, natural numbers, and integers. So like always remember that natural numbers are the numbers starting from 1 up to infinity. Then whole numbers is a set which includes 0. The integers is a superset of that which includes negative numbers as well. And all of these taken together form rational numbers or real numbers. So irrational numbers are not real numbers since they cannot be or p by q form. Okay. So next is make sure to learn all the prime numbers till 100. Next is advanced topics such as number of zeros or the highest power and unitary and digital root should be covered thoroughly. So digital root is something which you should remember. That is the sum of the digits of the number which should be added again and again until you have a single digit number. Okay. Next is the sufficient number of questions. You should practice on this area to get expertise. And when you practice questions in bulk, you will get better and better at it. We have a little quiz ready for you. So you guys should take this quiz. You can just scan this QR code or refer to this link. Yeah. So I hope you guys will be able to see the questions and we have a timer here. So please try to solve the questions among the dedicated timer. So the question here is if 1/3 of 1/4 of a number is 15, then 3/10 of that number is what? Okay. I'll just give you some hints. Okay, small hints. So it basically says 1/3 of 1/4 of a certain number, let's say x is equals to 15. Number is what? Which essentially means 3/10 of x is what? Yeah, so this is a simple question. So I believe you guys should have solved it. Okay, hurry up, guys. Whatever you solved, submit your responses. Okay, so 45, 33% of you show the leaderboard. Okay, Manisha, I see just 3 of you have submitted. The 4th person, are you facing any issues while submitting? Guys, are you facing any issues? So I can move on to the next question. You can just write in the comment section. Okay, never mind. We'll just move on to the next question. No, sir. Okay, okay, cool. Great. So 54 was the correct answer. Okay, now moving on. 3 times 3 times the first of 3 consecutive odd integers is 3 more than twice the third. The third integer is what? Okay, guys, solve this question. From next question onwards, we'll not wait. We'll just move on. So I hope that you guys are getting familiar to the platform. And this is this is an easy question. So you guys should be able to solve it. So, yes, see, 3 times the first of 3 consecutive odd integers is 3 more than twice the third. So what you'll have to do is you'll just have to multiply 3 times with the first of 3 consecutive odd integers. Okay, I hope you're getting it. It's not saying the first 3, but any consecutive 3. Okay, one of you has answered. Nice. Okay, so 67% of you says it's 11 and 33% of you say it's 15. Okay, let's see the answer. The answer here is 15. I can't see who answered that, but yeah. Okay, we'll move on to solve these questions, and at last I can answer all of them. Okay, it's Dhakshane Tharane MKS. Nice. Moving on. The difference between a 2-digit number and the number obtained by interchanging the positions of the digit is 36. What is the difference between the 2 digits of that number? See, we have discussed a shortcut trick for this. So let's see how many of you can solve. This is an intermediate question, and these type of questions are usually expected in exams. So you see, guys, here you have to just interchange the digit and find the difference. Yeah, the timer has started. A 2-digit number is such that the product of the digits is 8. And when 18 is added to that number, the digits are reversed. Okay. So what you can do here is you can just assume the values of the digits as variables and try to solve it. So let's see if you can solve it or not. 24. Arzu, please use the link to visit the quiz and you can solve it from there, or else you can just scan the QR code that is on the left hand side. So it would be easier, and you'll be in the leaderboard also. Yeah, thank you. Yeah, so this question is pretty simple. You guys should be able to solve it. Just assume the 2-digit number x and y. So x in tens digit and y in unit digit. So when 18 is added to the number, then the digits are reversed. Okay, time's up. Submit your responses. Okay, nice. Let's see what is the answer. The correct answer is 24. Okay, now moving on. The sum of digits of a 2-digit number is 15 and the difference between the digits is 3. What is the 2-digit number? This can also be solved in the similar approach for the previous questions. You just assume the values of the digits and you can solve it easily. Okay guys, 20 seconds left. In exams, you will be allotted like roughly 1 to 1.5 minutes per question. So try to solve that in the allotted time frame. Okay. One of you said cannot be determined, and two of you thinks is 96, and one of you thinks is 78. Let's see. Yeah, the answer is cannot be determined. Okay, there's fierce competition between Manisha and Dhakshane. So let's see who will win this. Moving on to the 7th question. The sum of square of 3 numbers is 138, while the sum of their products taken together at a time is 131. Then the sum is what? You need to find that. A number consists of 2 digits. If the digits interchange places and the new number is added to the original number, then the resulting number will be divisible by what? Okay, so one of you has answered 3 and 3 of you has answered 11. Let's see who is correct. Answer 11. Manisha has scored a 6 out of 7. Good going, Manisha. Moving on to the next question. In a 2-digit number, if it is known that units digit exceed its tens digit by 2, and that the product of the given number and the sum of its digit is equal to 144, then the number is what? Okay, so everyone seems that you have got the right answer, 24. Moving on. Find a positive number which, when increased by 17, is equal to 60 times the reciprocal of the number. The hint here would be, if you multiplied 60 to the reciprocal of the number, then it should come as a integer, or might you should say a natural number, not a fraction. So you can just think about it as a hint. Okay, so we have our responses here. 3 of you attended, and 2 of you think 3 is the answer, and 1 of you think 10 is the answer. Let's see which is the correct answer. The correct answer is here, 3. 3 when increased by 17 is 20, which is equals to 60 times the reciprocal of the number, which is like 60 times the reciprocal of 3, which is also equals to 20, right? So yeah, Manisha got it correct. And guys, pay attention to the time span that you're taking. Here you can see that Manisha is taking very less time than the rest of you. So try to solve it in a short period of time. Okay, moving on. The product of two numbers here is 9,375, and the quotient when the larger one is divided by smaller is 15. So what is the sum of the numbers? Just assume the values of the number as a and b. So AB is 9,375. And when the larger is divided by smaller, so expect the larger to be A. So A divided by B gives the quotient 15. Okay. Two of you think it's 400 and one of you thinks it's 395. So yeah, 400 is the correct answer. Manisha got this right again. Nice. Moving on. The product of two numbers is 120 and the sum of their squares is 289. So what is the sum of this number? Sum of the numbers, obviously. Okay, one of you has answered. And just assume the two numbers as variables and solve the equation. This is simple. You should try to see what are the sum of the two numbers. You can clearly see that the product of the two numbers is 120. So see, you can also use the a plus b whole square expansion, which would be easier. Here you have ab is 120, a square plus b square is 289. So you can clearly find out. Okay, two of you think it's 23 and one of you think it's 169. Okay, let's see. Yeah, the correct answer is 23. Moving on. A number consists of 3 digits whose sum is 10 and the middle digit is equal to the sum of the other two, and the number will be increased by 99. If its digits are reversed, then the number is what? Okay guys, here the basic approach should be to imagine the number. Like if you can just think what it should be, then it would be easier for you to solve this. Okay. So if you just consider the three numbers x, y, z, then x plus y plus z, we have 10. Okay. And the middle number, that is y, is equal to the sum of other two, that is x plus z. And when the number is increased by 99, then digits are reversed. Okay. 3 of you thinks it's 253 and 1 of you thinks 145. Let's see. Yeah, 253 is the correct answer. Good job, guys. Last but one question. The sum of two numbers is 25 and the differences is 13. Find the product. It's very simple, guys. You have a plus b is 25 and a minus b is 13. You have to find A multiplied by B. Okay, guys, hurry up. This is a pretty simple question. You should be able to solve it even without using a paper and pen. Okay, the sum of numbers is 25. So let's assume the two numbers A plus B. A plus B is 25. Difference is 13. A minus B is 13. Just add them, add the two equations. So 2A equals to 38, A equals to 19, B equals to 6. Just multiply 19 and 6. Yeah, everyone got the right answer. Congrats. Now moving on to the last question. What is the sum of two consecutive even numbers? The difference of whose square is 84. Guys, just assume the two numbers as n and n plus 2. Okay. Or you can just take it n or n minus 2 since our two consecutive even numbers are separated by a value of 2. And the difference of whose square is 84. So basically n square minus n plus 2 whole square is 84. So the n square term will get cancelled out. You will have, this should solve it. Okay, so three of you thinks is 42 and one of you thinks 46. Let's see. Yeah, 42 is the correct answer. Yeah, similar to previous one, correct. So Manisha is winner of today. And the hardest question was the sum of two digits is 15 and the difference is 3. Only one of you got it right. So Manisha, I'll go back to that question. So 96 and 69. Where was it? Yeah. The answer is cannot be determined because here it is specifically asking for what is the two-digit number. Okay. So from this, you can easily calculate whether it is either it is 96 or 69, but you cannot pinpoint exactly what the number is. I hope you're getting me. So you need to find out exactly what the number is. So you cannot determine that, right? So the answer would be cannot be determined. I hope I'm clear. Okay, guys, this was just the first preliminary quiz to get you acquainted with the session. So next class we'll have a pretty much difficult one, which will contain a more advanced questions, and I'll suggest you to prepare accordingly.